Hello there. In this video, we are going to be solving some try questions. So our first question we'll be solving is a cyclist riding a bicycle is moving along a straight road with an initial speed of what 25 kilometers per hour. So we are given our initial speed or initial velocity of what 25 kilometers per hour. So that is what our initial speed or velocity, and the bicycle is then uniformly accelerated at 5 meters per second square. So we are giving our acceleration to what 5 meters per second square, and the question says you should determine the time required for the cyclist to reach a speed of what 81 kilometers per hour. As you can see, there are different units here. Our first unit is what kilometers per hour, and the second one is what meters per second, but we want it in what meters per second. In this linear motion, we mostly deal with what meters per second. So that means you have to convert the kilometers per hour, because all of them have to be in what 1 unit. So you have to convert the kilometers per hour to meters per second. So as we know, it's just we know that 1,000 meters will give what 1 kilometer. So in place of the kilometer, you just put 1,000 there, and we know that 1 hour will give what 3,600 seconds. So in place of what the hour, you just put what 3,600. It's simple as that. 25 multiplied by what kilometer, and the kilometer, we know that kilo is what 1,000, is a prefix for 1,000. Just put 1,000 what meters, so it's a prefix for 1,000. So you just put what 1,000 meters. So 1,000 meters there. So in place of the kilo that was here, we've put in what the value, which is what 1,000. And our hour, in place of the hour, what it was 3,600 what seconds. Just simple as that. And you multiply it, and you are going to get what 6.94 meters per second. So this is what our what initial velocity. Our initial velocity is 6.94 meters per second. We move on to what the next convention, which is the 81 kilometers per hour, and we are changing that one towards meters per second. So same, it changes what kilometers per hour. So our k is here, our h is kilometers per hour, like this. In place of what the kilo, we put 1,000 there, and in place of the hour, we put what 3,600 seconds there. Do you get it? 3,600 seconds there. So it's going to what 81 multiplied by 1,000 what meters all over what 3,600 seconds. So supposed to be what 1,000 meters all over 3,600 seconds, and we are going to get what 22.5 meters per second. You get it? So without this convention, if you just do it in the kilometers per hour, you think you've done it, you've used the equation to solve it, but because of the unit, you'll be wrong. You get it? So let's move on. It say we are finding what the time required to reach what velocity of what 81 kilometers per hour, which if when you converted it was 22.5 meters per second. So first, when we are given a question, you write all the parameters down. We know that you write it down. We know v, we know u, we know a, but you are looking for t. Among all the three equations, the first one is the easiest to use because we don't know s, and the other two equations would involve s, which is the displacement. You don't know the displacement. So the first equation is the easiest one to use. So it's going to be our v, which when you converted, we had 22.5 meters per second. We are just substituting them in. Our u, when you converted, we have 6.94 meters per second. Our what acceleration was 5 meters per second. You just put it inside, and here we are making t the subject, so you have to what subtract 6.94 from both sides, or what you move this one to this side of the equation, giving you 22.5 minus 6.94. Do you get it? So if you subtract 6.94 from both sides, so here is going to be minus 6.22.5 minus 6.94. Here is going to be 6.94 minus 6.94 plus 5t. So it's going to give you what 5t 5t plus, since that one is going to give you, plus 0 is equal to what? 22.5 minus 6.94. And since we want this to be alone, we divide both sides by what? 5. We divide that 2 by what? 5. Our 22.5 minus 6.94, and we are going to get what? Our t to be what? 3.11 second. Do you get it? The reason why I'm not writing a lot is because of my mouse pointer. So you are going to get t to be what? 3.11 second. That's the time required for it to reach what? A velocity of what? 81 kilometers per hour. Do you get it? So let's move on to the next question, which says a train is traveling at 90 kilometers per hour. A train traveling at 90 kilometers per hour is brought to rest with a uniform retardation of what? 0.5 meters per second. So first we are looking at what? The time taken for what? The train to stop, and the second, the distance traveled before coming to rest. So here, what were you given? We were given what? Our it says is traveling at, so that means this is our initial velocity, which is what? 90 kilometers per hour. Initial velocity. We are given uniform retardation. This is the opposite of what? Acceleration. This one too is what? Change in velocity here, but here the change is from what? A higher velocity towards a lower velocity. It's called a retardation, and it's what? Always in the negatives. So the negative of acceleration is what? Retardation. So first, as we know, we have to convert the 90 kilometers per hour to what? Meters per second, which is going to be what? Times 1000 over 3600, which is going to give us what? 25 meters per second. Do you get it? So we move on. Since you are finding the time required for it to what? Stop. The time for it to what? To stop. That means at the stopping point, that means it will move. The time required for it to stop. So that means if it stops, there is no velocity. That means our final velocity is 0, because when we are saying for it to stop, the final will be what? 0, because when it's at rest, there will be no what? Velocity. That will make what? Our v to be what? 0. So we just take your first equation. As I said, you look at the most suitable equation to use, and here, since you were given what? We are given a, and we know for it to stop, our v will be 0. This will be what? The best equation for us to use. So you just put your v, which is 0, u, which is 25 meters per second, and as I said, it is negative of what? Acceleration. So since we are given to 0.5, you do it what? Minus. So it's going to be minus 0.5. So because of that, it's going to be 25 minus 0.5 t, and what? You bring it to the other side of the equation, making it what? 0.5 t is equal to 25. And if you divide both sides by what? 0.5, 0.5, 25 divided by 0.5, or 25 divided by half is equal to what? 50. Well, it's the same as 25 times. If you reciprocate it, it's going to be 25 times 2, giving you what? 50 seconds. So our next one says you should find the distance traveled before coming to rest. So distance traveled before what? Coming to rest. They are basing on the rest. So that means what? Our final still remains 0. So distance, so you are looking for distance, which is s. Do you get it? So you look through all the equation. For the first equation doesn't have s in it. You come to the second equation. We have what? Our v squared, which is 0. We have our u, we have our a, but we don't know s. So that means what? This equation is what? Suitable. You can use the what? The third equation too, but that one we are going to use the t we found for first. But it's, I won't advise you do that, because let's say in an exams you get the t wrong, that means you also get what? This question wrong. So it's better to use this one, because what? All of them were given from what? The question. So v squared, 0 squared is going to give you 0. 25 squared is going to give what? 625. Multiply by 2 times what? 0.5s. 2 times 0.5 is going to give, is still what? 2 times negative what? Half, giving what? Negative 1. Negative 1 times s is going to give you negative s. So you just say you add s to both sides, or you bring s to the other side of the equation, making what? Your s or your displacement to be what? 625 meters. So it will move 625 meters before it will come to rest. Do you get it? Thank you.